So let me introduce you to a graph. My graph here talks about a strep test. Let's say we call this strep 1.0. And what I'm saying here is that this is how many false positives it gives me, and this is how many true positives it gives me. And so, as you can see, we have quite a bit of false positives here. So clearly it's not too good of a test. And so let's say a researcher develops an updated strep test. We're going to call this strep 2.0. So let's say strep 2.0 is said to have a higher sensitivity with no change in the specificity of the test. And so if I show you a couple points, where would you have a test that is more sensitive and no change in specificity? And so is it A, B, C, or D? And I'll let you pause here and think about this, and if not, we'll move on to the answer. And so the correct answer here is B. B is more sensitive and exactly as specific. And so the graph here is called an ROC curve. And ROC just stands for receiver operator characteristic. You really don't need to know why that's important, but it comes from military fighter planes. So all we're saying here is that we have true positives. And if you recall correctly, true positive means the same thing as sensitivity. And so what we're saying here is that we have 100% sensitivity up top and 0% sensitivity on the bottom. And so we want a test that is more sensitive than this initial point here, strep 1.0. And so we know that anything below this line is less sensitive. And so that means that A and D are wrong. And now we're left between B and C. Well, C kind of changes on this x-axis. And if you recall here, our x-axis is false positives. A different way of saying false positives is 1 minus specificity. And so as specificity goes to 0, we end up at 1 on this side. And so what I'm saying here is that we have a more specific test over here and a less specific test over here. And so C is less specific. And we are left with B, which is more sensitive and equally specific. I wrote that out here a little more clearly. Basically what that means is that our y-axis is sensitivity and our x-axis is 1 minus specificity. And so we have tests that are more specific as they go to 0. And so just recalling stuff from earlier videos, we have our false positives, we have our true positives, and if we have a 50-50 shot of getting this right, this would be called random guessing. And this would be something like a good test because it mostly avoids false positives and most of your answers would be over here. I hope that helped. If you have any questions, leave them in the comments and I'll try to get back to you. Thank you.